Okay, we're going to get into the incredibly important chapter 3.5, Dividing Polynomials. And for this, you're going to have to review your knowledge of long division, really. And here's the main things you're going to have to remember. And that is sum and difference of cubes. So whenever you can't remember difference of cubes, something I meant to look up here. Whenever you can't remember, just remember that there's always a nice, easy Google that will show you. And I actually like this summary best, right here. And you'll notice that in the sum of cubes, this is always a factor. And then difference of cubes, this is always a factor. And that's important to remember. And then the middle point will not be factorable, but will always be this formula. The difference for this difference of cubes is they're all added. And the difference for the sum of cubes is this first term here is negative. So if you can just sort of remember that, that'll help you. And just remember that the second thing is the first term squared, the last term squared, and the middle, just the two terms multiplied by each other. And as I mentioned, the signs negative and positive. So that's something to remember. Now the other thing to remember is exponent laws. So if you remember x to the 3 times x to the 4, the secret is we're going to add those exponents. They can only be added when the base is the same. So that's going to be equal to x to the 7. And the reverse is true. When you're facing x to the 7, you can break it down any way you want in order to work with something you need to work with. The other thing to remember is division. So x to the 3 divided by x to the 1 is you subtract them. So that's going to be x squared. And finally, remember that an exponent of an exponent is the time that you multiply the exponent. So x to the 3 to the 4 is x to the 12. These are important because here when we're factoring or dividing polynomials, you're going to have to figure out how to turn x to the third into x to the fourth and what you would multiply it by and how to factor out and all that sort of thing. Let's look at finally long division. You're going to remember your factoring and expansion, but also long division. Remember these terms. The divisor is the term you're dividing into, the dividend, and what's left or what you solve at the top is the quotient, and sometimes down here you're going to have the remainder. Now what's interesting is a zero remainder means that is a perfect factor, and anything else means it is not. And we're going to get into that. I want you to look over here. This is clearly a parabola. And I want you to notice that the roots are the opposite of the factors. So the plus 6, the root or the x-intercept is minus 6 comma 0. The root here, it's plus 3 comma 0. That's important. I want you to notice that if we put any of these roots into the formula, if I put 3 into this formula, 3 minus 3 is 0. 0 times this 9 is going to be 0. We will get a result of 0. And that will always tell you that the root is a perfect factor of this. And I want you to keep that in mind. Same if we put the minus 6 in here for x, this becomes 0. And minus 6 times 0 times minus 9 is still 0. Which, that explains why it's an x-intercept, because the y result is 0. But also that it will be a perfect factor. I want you to remember that. Now let's say we expand that. What do we get? X squared plus 3x minus 18. Okay. I want you to treat that, and you're just going to have to remember these things here. I want you to treat that like a dividend. So something we're going to divide into. Minus 18. And remember, it's squared here. And I want you to treat it like a long division. And we're going to take something that we suspect is a factor. So we're going to take x plus 6 as a factor. Now you might say, I can't see how you can long divide that. Well, focus on just the first letter. What do I have to multiply x by to get x squared? Well, it's clear there, or if you want to reverse it, when I take x squared and divide it by x, what do I get? But I like to think instead of what do I have to multiply x by to get x squared? Well, it's clear it's an x. So now when I take this x and I multiply it here, I get x squared, which is what I want. And now I multiply it by the next term. I get plus 6x. And this is how you do long division. Now, like any long division, you subtract this part from this part. So clearly that's 0. And then plus 3x minus 6x becomes minus 3x. And then you bring down the minus 18, which is what you do in long division as well. And now we say, what minus 3x? What do I have to multiply x by to get minus 3x? Well, it's clear. I have to multiply it by minus, oh, did I do that one right? Plus 6x. Oh, I did the middle term wrong. Hang on. Minus 3x plus 3x. 6x is plus 3x. And then minus 18. Yeah, no, I did that right. But that's not giving me the right thing. It shouldn't be minus 3. It should be minus 1. So x times minus 3x plus 6x minus 18. X squared plus 3x minus 18. Oh, I see what I've... No. Oh, no. It is the right thing. Sorry. It's a 3 over here. Sorry. My bad. So if I multiply, how do I get x into minus 3x? I have to multiply it by minus 3. And when I multiply it by minus 3, I get minus 3x. And then when I multiply the minus 3 times the plus 6, I get minus 18. And when I subtract it, remember that these both become positive, and I get a remainder of 0. And that's the clue. When I get a remainder of 0, this indeed is a factor. What is the leftover factor? Well, look at that. It's the factor we were looking for. It's x minus 3. The same thing will happen if I start with x minus 3 here. I'll end up with x plus 6 up here, and I'll get a remainder of 0, which tells you when you get a remainder of 0, they are indeed factors. So learn the long division. It's very important. Let's say instead I didn't have x squared plus 3x. Let's say I had x squared plus 3x minus 19. And I was trying to see if, and remember it's squared here, and I was trying to see if I could factor in, let's bring it down a bit, the x plus 6 again. The x plus 6 again, to see if it's a perfect factor. So I'm going to take the x plus 6, and you ask yourself, how many times does x go into x squared? It goes x times. Then you multiply it by the x, you get x squared, and by the 6x, you get plus 6x. And then you have to subtract it, you get minus 3x. And we notice, and then we bring the minus 19 down. And we notice minus 3 does indeed get us minus 3x, but it gets us minus 18 as we learned before. And when we subtract it, we're left with a remainder of minus 1. That remainder tells me this is not a factor of that, and which doesn't have a factor. And you would rewrite, but you could still rewrite it as factored like this. X plus 6 times x minus 3, and all that at the end has a minus 1. Which means if I were to expand this whole thing here and then subtract 1, I will indeed get what I started with. And that is very true. And that's interesting. That means you can manipulate, just like completing the square, we can manipulate things to be factored and just create a remainder here. And it's the same with this. They give you an example in the book to show you a remainder. And you can either write it as these are the factors and this is the remainder, or you can write it as that. You can also write this as, I believe, minus 1. I'm going to get back to that. You'll get more into remainders later. And technically that minus 1 is indeed over, I believe, x plus 6 is the actual remainder. But we're going to get more into that. You would write it just like this, though. So that's an important thing to remember. Now, the other thing you're going to learn in this is something called synthetic division. Synthetic division. Let's go back to our basic thing, which was x squared plus 3x minus 18. We know that has factors of plus 6 and minus 6, or roots of. So we know that factors are x plus 6 and x minus 3, which means the roots are minus 6 and plus 3. The roots are the opposite of the factors. And now we're going to learn synthetic division. So we're going to focus on minus 6. So I want you to notice the numbers in front of each and just bring them down. We're working with 1. That's a 1 there, not a 0. Plus 3. Minus 18. And here's how synthetic division works. We're going to take the minus 6, which is we're going to see if it's a factor. And we're going to just bring the 1 down. So the 1 comes down. We're going to multiply this by minus 6. Put it there. And we're going to add these. Plus 3 minus 6 is minus 3. Then we're going to multiply that by minus 6. And we get plus 18. And we're going to add them. And we get 0. We get a reminder 0 here. And then we're going to remember that we started with x squared, x, and 18. And the x's we put here are 1 less than what we started with. So I'm going to put 1x minus 3, which is also x minus 3. So now notice that we got a factor here of minus 6 because we got a remainder of 0. And one of the other factors we came up with is x minus 3 right there, which means that x plus 6, which is the opposite of the root, these are indeed our two factors. Synthetic division is much faster and very powerful and will give you the same remainder as long division. But this section wants you to learn both. Oh, one thing I'm going to keep around is that sum of cubes and difference of cubes. So in the book, they're going to give you an example of a long division that has a remainder. Then they're going to show you how to do the same thing with synthetic division. It's very important that you put your terms in the right order. And when you're missing a term, put 0 in whatever the term should be. So for instance, if this wasn't there, you would put plus 0x squared as a term. And that's because you want to represent that in the column. And synthetic division will indeed give you the terms and the remainder that you would have gotten with long division. And they want you to just learn that. And then they want you to practice it. Now notice here you have to put it in the right order. That's first. That's next with the minus. That's next, and that's next. And the same with this. You have to put it in the right order, which they do here. And then you have to do a long division. Very important to practice it, otherwise it's a pain. So here they're asking you to figure out the roots and then to use that in synthetic division. And then they get you to figure out what's the leftover factor and see if you can factor that. And they factor it. How do they reach the conclusion? Oh yes, so that's an important step as well, is if you did factor something out here to create the synthetic division, you must then, if you factored out a 2 to figure out the correct division, you must put it back in. That's one way of doing it. You can also, so here's what they did. They're saying if you are trying to figure out if this is indeed a factor, you should factor out this 2 first, and then figure out that this is the root here, the opposite, minus 3 over 2, and work with that. But I would suggest instead, don't factor it out, and work with the yeah, they're kind of doing an extra step. You could have just made that equal to 0 to figure out minus 3 over 2. They're saying, though, once you factor this out, because you factored out 2, you have to do the same for the leftover polynomial. And that's important to realize, that if you factor something out of the thing you're using synthetic division, you must put it back. So that's why they multiplied the remainder here by a half, because it was essentially divided by 2. It would have been divided by 2 right here, which is the same as multiplying by half, to get the actual terms. So the actual terms are these. Once you have those actual terms, notice that the remainder is stated as a 0 over this. Once you have those actual terms, and these are the terms there, you then should be dividing them by 2 to get the real terms. That's essentially all they're saying. It's a little complicated. You'll see it more the more you do. And then you can figure out the actual x-intercepts, because that last one, this one here, is factorable. It's 3x minus 5 and x plus 1. Again, the more you do it, the easier it is. But I think the point is, synthetic division can get tricky if you've factored out a number. Let's just do them. Doing is a lot easier than trying to understand. You always want to keep in mind to spot if there's a difference of cubes. Oops. But we'll just leave difference of cubes on this page, and I'll start a new page instead. And they want you to start by doing long division. So they want you to take this polynomial and divide it and see if there's a remainder, because the next question is, are they a factor? And if they are a factor, there will be a remainder of 0. So again, treat it just like long division. Make sure your terms are in the right order, and they are. And follow along. So x cubed is what I would have to multiply x by to get x to the 4. And then I actually do multiply them. I get x to the 4, and what's x to the 3 times minus 2? It's minus 2x to the 3. Then I subtract them, just like every long division. This becomes a positive, and I get minus 14x cubed. Then you have to bring down the next one. And if I go too slow, just play me at 1.5 times the speed. Then you have to ask yourself, what do I multiply x by to get minus 14x cubed? I multiply it by minus 14x squared. That's where your rule of exponents comes into place. So then I just multiply this times that, and this minus 14x squared times the minus 2, and I get plus 28x squared. Then I subtract, these become 0, and this becomes minus 24x squared. Then I bring the next number down, plus 10x. And I ask myself, what do I have to multiply x by to get minus 24x squared? I have to multiply by minus 24x. And when I do, I multiply here, get my minus 24x squared, and then I multiply it by minus 2 to get plus 48x. And then when I subtract that, I get minus 38x. Then I bring down my last number, minus 11. And I ask myself, what do I have to multiply x by to get minus 38x? Well, minus 38 is the only thing I can put in there. And I get minus 38x. And when I multiply by minus 2, I get plus 76. And when I subtract that, I get a minus 87 remainder. Now, since I didn't get 0 as a remainder, that is the remainder. So then I could rewrite it as x minus 2 is one of the factors, and the other factors is x to the 3 minus 14x squared minus 24x minus 38. And finally, my remainder is minus 87 over x minus 2 because it didn't go in. And then don't forget to put your right powers over top. So this is a cube, this is a square, and that is just x. And there you go. This is the remainder here. Now, really, I should have the answers open to verify this. And I might get a numerical error somewhere along the way, but this is indeed the process. You can also get away with not writing this as a remainder like this. As an equation, you would just write it like that. And that's because when I finish expanding all this, and subtract that, I will get what I started with. And you can quite easily see this as minus set 2 times minus 38 is plus 76. And when I subtract the minus 87, I do indeed get minus 11. So you just actually write it like this. You wouldn't put it as x minus 2. You just have to understand that that's what was left. I believe if it's written in the bracket, that's how you would write it, in the bracket. So if you're going to leave it in the bracket, you'd have minus, geez, what was it? 87 over x minus 2. That's how you'd write it if you're going to include it with this term here. And that's because when it multiplies out here at the end, it cancels out with that, and you get just the minus 87. So if the minus 87 is outside the bracket, it's just like that. And if it's inside the bracket, which is the full real factored form, then you'd have to include it with it. And that's the difference. Sorry. My brain kind of farted on that one. And then you just do the process again for the next one that they're interested in. And it's very good to do it because I'll tell you that it's very easy to make a mistake on these things. And the more you practice, the less mistakes you'll make. So what do I have to multiply x by to get x to the 4? It's x to the 3. When I multiply it, I get x to the 4. And then when I multiply it by the 4, I get plus 12x cubed. Then when I subtract it, I'm left with minus 38x cubed. Now I have to bring down the next number. And I have to ask myself, what do I have to multiply x by to get minus 38x cubed? Well, minus 38x squared. And you'll see a little pattern here. It's like one less power than this thing when it's an x we're dividing into. When I multiply it out, I get minus 38x cubed. And when I multiply, and that's a square up here, sorry about my writing. When I multiply it by the 4, I get plus 4 times minus 38, 76, 152 x squared. And then I have to subtract them, and of course these cancel out. And I'm left with minus 148x squared. That's this minus that. And I have to ask myself, what do I have to multiply x by to get minus 148x squared? Well, it's minus 148x. And when I multiply it by x, I do indeed get minus 40x squared. And when I multiply that by 4, I get minus, it's 600 minus 4, 596x. And then you also have to remember that we're bringing down the 10x. That's the next number. And when I subtract it, I'm now going to add it. And I'm going to get 604x as the remainder. 604x. And then when I bring down the last number, I have an 11. And it's quite clear that the last one's just going to be as chaotic. I have to multiply by 604x. Or just 604 to get 604x. And the remainder is going to be plus, it's going to be crazy. It's going to be plus 24, or 12, something like that. And when I subtract them, I'm going to be left with a remainder of negative 2423. Now my arithmetic might not be correct there, but the process is correct. So the factors are x plus 4 And then I'm left with x cubed, and I'm looking at the quotient at the top, 38x squared minus 148x plus 604. And then if I close the brackets, I can just put the remainder out there. That's assuming I got my remainder right. And then don't forget that this is a cube and this is a square. And if I don't want to write it like that, if I want to write it as if it's inside the brackets, the secret is just to bring the bracket outside like this and make sure that you represent the remainder as a factor, as a fraction. Now this will become more important as we go into calculus of understanding the difference. And if you want to understand the difference, you can simply expand it. You can simply expand this way, or expand it the way I had it, and you should get, and this would be expanding it this way and then subtracting 243, and either way you do it, you should get the original quotient. It was a quotient? No, dividend. No, quotient right there. And again, try to remember your terms for various things. And if you ever forget it, you can just go terms for dividend and click on images, and you should see all three explained. Yeah, quotient's up top, dividends in there, and 4 is the divisor, and the remainder's there. So it's important that you remember those terms because you will have to express it in words sometimes. So there we go. Okay, we're going to just continue. And then they ask you to do it again because practice makes perfect for x minus 1. Now notice how long it takes, and that's where synthetic division is quite nice. Synthetic division, as long as you don't make a standard mistake, is much faster than long division. But they want you to understand the connection. And they also want you to have the ability of understanding how these things work. They work as if these are all numbers. They work with the same math principles as numbers do. And it's important to make that connection. So I'll see if you can follow along what I'm doing. I'm simply multiplying by both these things and putting it on the next line and then subtracting it. This minus minus becomes a plus, and I get minus 15x cubed. And then I just have to lower the next term. And we'll see if you can figure out what I do here. And I'm just going to leave like that and make sure there's no sign of a minus there. And that's a cubed. And I get minus 15x squared. So I get minus 15x cubed plus 15x squared. When I subtract it, I get minus 11x squared. That's plus 4x squared minus 15x squared. So minus 11, and it helps if my writing isn't lousy. And then I did bring down the next number. Sometimes you'll have nothing here for x, and what you would bring down is plus 0x. And that's important to know as well. And then my next factor is minus 11x to get minus 11x squared. And I end up with plus 11x. And when I subtract them, I get minus x as a remainder here. And then finally, I bring down my last number. And I have to multiply it by minus 1. And I get minus x plus 1. And when I subtract it, I'm left with a remainder of minus 12. Which means, if I'm going to write it as a long division factor, it's this. And then I just read the quotient at the top. X cubed minus 15x squared minus 11x minus 1. And if I put the remainder outside the bracket, it's minus 12. And I just have to remember to do that. And as I said, if I'm going to put the remainder inside the bracket, I have to put it as a fraction over the divisor. So again, this is the divisor, this is the dividend, this is the quotient, this is the remainder. And the remainder can be expressed in two ways. Either way, if I expand this, or if I expand or if I expand that, I should get this. Are any of the binomials in part A factors? No, they are not, because they all had remainders. If the remainder had been 0, they would have been factors. State the degree of the quotient for each of the following dividends. So this is a little easier. They don't want you to do the actual dividing. They want you to figure out, if I take this and I divide it, if I take this and I divide it by this, what will be the biggest degree of my quotient, of my thing at the top here? Well, since I'm taking x, I look at the biggest value. X to the 4 is the biggest value. Always look at the other ones to make sure. But x to the 4. And if I take x to the 4 and I divide it by x squared, you can forget about the minus 4. You have to use your rule of exponents and realize that the biggest exponent I'm going to be left with, the biggest degree in the quotient, is going to be x squared. So the answer to that is, what is the degree of the quotient for each of the following division statements? So it's going to be x squared plus x plus a number. And that is because when I'm dividing, and the remainder is going to be something like x minus 10, or an x minus 10 amount, because this last part can't be divided by x squared. So only this part can be successfully divided, and then you're going to have a remainder plus all this stuff, and you can add the number with that number, and this will be the remainder. But the leading term will be x squared. So that means the degree of the quotient will be x squared. Same with the other ones. If I divide by this, which I believe is a third here, that's a third, and that's a square. This is an x, and this is a third, which means the leading quotient, when I divide this by that, will be x squared. And the next one will be an x, the next one will be a number, and because this minus 4 can't be divided by x, I'll be left with a number as a remainder. So this part can be divided by x, but this part can't. So I'll be left with a number over x plus 3 as a remainder. Unless it goes in perfectly, then that number will be 0. Okay, let's continue. What about this one? Well, this is interesting because I have an x to the 4 is the biggest power and an x to the 3, which means this will successfully go into that x times, and then it'll be left with a number. And then I can't divide it into this or that, so my remainder is going to be x squared plus 9x plus some number. And that's all you're going to get out of it. Interestingly enough, if you put this in Desmos and divide it by that in Desmos, it will show you the graph of what's left over. So just as an example, if we go to Desmos and I make f of x equal to 5x cubed, to the 4, plus 6x cubed, plus 4x squared, plus 2x plus 7, and I make a g of x equal to a cubic 3x cubed plus 2x squared plus 4x plus 3, and I make my h of x equal to f of x divided by g of x. In other words, I'm dividing those polynomials. It will show me a graph that looks like this. And you can see that we end up with what's essentially a rational function. And that's because this cannot be perfectly divided into that and create factors. You'd be left with a whole bunch of x squareds plus 2x plus what, all with a division, like being divided by that, like if the remainder's in fraction form. And that remainder in fraction form will create a rational function. So that's interesting to note, that when this is much, much too big in terms and you have these leftover terms will be expressed as a fraction over all of g of x, which will create this. That's important to remember when we get to calculus, because in calculus they're getting you to figure out the rate of changes of numbers in weird functions like this. Let's change this and just make it a normal 4x plus 3 and see what happens. Oh. So when we see it like this, we can see there's no pure factors. Let's just do x plus 3. And when we do it like that, we can see that there's just a parabola left. Or actually, that might be a cubic left, which makes sense because if I divide this by power to x, I'm left with a cubic. That's more of an aside than anything, but it's just sort of an understanding of what you're left with. Complete the divisions. Oh, they want you to go ahead and complete the divisions up here. Oof. I might have to take a break after 4 because these things are so long to do it, long division. I'll try to do 3 and 4 here. So complete the divisions, one by one, complete the divisions. And then they want you to complete the table. So they want you to take this. I guess it's useful. Are all the terms complete? Yes, they are. This one, however, notice this one, we're missing a term. We're missing an x in there. So it's 0x. So normally you might want to put it in there to understand what's going on. But let's just see, you know what a good thing would be is to put that into Desmos divided by that and see if we get the same as our, if we just put our formula in as a remainder, we should get the same graph. Okay, long division. You'll see the problems here. If I'm going to get my x squared to x to the 4, I have to multiply by x squared. And I'm left with x to the 4 minus 4x squared. So right away I can see I got a problem here, which is why technically this dividend over here should have a little extra term in it that is plus 0 x. And that's because there's a missing term between x squared and x plus 4. Another way to look at it is x squared plus minus 4 is the same as x plus 2 and x minus 2, and we're essentially dividing that whole thing into this, but it's not very easy to do. But this is a long version of that. That's why difference of 2 squares exists, because the middle term cancels out. So now if I do it properly, I can see that I have to multiply by x squared, and I get x to the 4 plus 0x cubed minus 4x squared. Now my minus 4x squared is under the right spot. And when I subtract it, I get 0. I'm left with minus 15x cubed. And then when I subtract this, I'm left with plus 6x squared. That's very important to include the missing terms. So now I have a minus 15x cubed. And how much does this go in there? Minus 15x. And if I multiply it down, I get minus 50. Oh, now we have to bring down the next term as well. And if I multiply this minus 15x times this thing here, I get minus 15x cubed, which is what I want. I get 0 plus 0, and then I get minus, or plus rather, 60x. Then when I subtract it, this cancels out. I'm left with 6x squared because of this 0. And then I'm left with minus 48x. Now I can do one last division. I have to bring down this minus 10. I'll bring the whole thing to the left a bit. And I can say, okay, I can put plus 6 times 6x times x squared gives me my 6x squared, times the 0 will give me 0, and times the number I'll be left with minus 24. This allows me to subtract like terms. And when I subtract it, I can see I'm left with a remainder that's quite complicated. And the remainder is minus 48x. And when I minus 2, I'm left with minus 8. And that's the remainder. So I would write that now as this. X squared, and I'll just put it in there in a second, minus 4 creates the quotient, x squared minus 15x plus 6, look up top, with a remainder of minus 48x minus 8. Now I want to show you something interesting. Hopefully I did all those divisions correctly, because I'm going to put this into Desmos and divide it by that to show what the graph is. And then I'm going to put this into Desmos to show what the graph is. And then I'm also going to put this into Desmos. To hopefully show that all these graphs are the same. So the first thing I got to try to put in is the original graph. So I'm going to go back, and I'm going to say f of x is equal to x to the 4 minus x cubed. I think that was the start of it. Minus 15x cubed plus 2x squared plus 2x squared. And then I'm going to have plus 12x. And then we have minus 10, which I believe is it. Then I'm dividing by x squared minus 4. So I'm going to make my g of x equal to x squared minus 4. Just like that. By the way, that's the difference of two squares. It'll have its factors there. Now I'm going to just turn that off. And I'm going to make my h of x equal to my f of x divided by my g of x. Okay, it doesn't matter what it looks like. Now I'm going to rewrite. I'm going to create a new one. I'm going to call it m of x. And I'm going to rewrite my full factored form right there, x minus 4. I'm just going to turn it off to see if we get lucky in the graph. Now I'm hoping my blue graph will match my red graph. And I get x, oh, don't forget that this is x squared here and x squared here. X squared minus 15x plus 6. And what was my remainder? Minus 48x minus 8. Now, so I did a calculation error somewhere. Minus 15x plus 6 minus 48x. Probably did a minor error somewhere. But let's try doing it like this. And if I did an error there, then it's probably going to be an error here as well. It could be just that I forgot a bracket here. Yeah, so I did do an error somewhere. Yeah. So that pretty much confirms to me that I did an error, because it certainly should have come out as the same graph. So that means I did an arithmetic error somewhere. Okay, fair enough. Let's see if I can spot it since I have the graphs. And I know you might say, oh, that's a waste of time. But really, this is a really good point I'm trying to make. And I want to try to do it properly. So it's going to be divided by this x squared. So you have to put in that extra term plus 0x. Otherwise, it's going to screw it all up. Either that or just remember to put in the right terms under the right terms. So it's definitely x squared. So that's correct. And I get x to the 4 plus 0 minus 4x squared. When I subtract that, I get minus 15x cubed plus 6x squared. The next thing is definitely minus 15x. I get minus 15x squared plus 0. And then I have to bring down plus 12x. And I get plus 60x. So that's definitely minus 15x. When I subtract it, I get 6x squared, because that's squared. And then when I subtract, I get minus 48x. Okay, then I've got plus 6. So far I did it right. Plus 6 to get 6x squared. And then it's plus 0. And then the remainder up here is minus 10 when I bring this down. And the multiplier is minus 24. Ah, there you go. That's where I screwed up right there. When I minus it, I get minus 48x, which is correct, but I get plus 14. That's where I screwed up. Plus 6 times minus 4 is minus 24, and when I subtract it, it becomes addition, and it's plus 14. So that is not minus 8. It's plus 14. You can see it as a plus and this whole thing. So let's see if that is a better correction. So I got everything else right except the number at the end. Well, it should have been the same graph. Oh, actually, no. You know what? Blue should be the same graph as this. And it's not. So I'm making some error along the way. And that's the problem, is if you can't spot these errors, it's not a good thing. Because my blue graph here should result in the same thing as my purple graph. Oh, geez, there you go. There you go. So when I take this and divide it by that, and then when I express it as a factored form, this should be the same as that, not the division. So there I got that right. The division should be the same as the quotient. So n of x is equal to that. So let's see if the division is the same, but you have to represent the quotient like this. And now my green graph should be the same as my H graph, and they are. There we go. So that's the distinction. This as a factored form is the same as this. And this part here, which is the quotient right here expressed properly as a fraction, is the same as dividing them. And that's where you got to compare it, because this here's the quotient, and this here's the quotient, and this here's the full equation, and this here's the full equation. Just this is in factored form. Now theoretically, I can also express this like this, and it will come out the same as the purple. And it does. There you go. That's all comes down to a couple arithmetic errors. I forgot a square here, and I didn't do the proper remainder. Yikes. That's why long division can cause you a lot of headaches. I'll try to do the other ones quickly, because as you can see, I'm prone to making mistakes. But again, the technique is correct. This one has all the terms, which is going to be a lot easier. X goes into this 5x times 5x squared, left with 5x cubed plus 15x squared. When I subtract it, I get minus 19x squared, and then I bring down the plus 3x. I get minus 19x as a quotient. When I multiply it out, I get minus 38 minus 76x. When I subtract it, I get 79x. And when I bring down this minus 4, I get that. So I get plus 79. So I get plus 79x, plus 210 and 8 and 27 is 237. And when I subtract it, I get minus 233. So that's the remainder. Now I might have done it incorrectly because I did it so fast, but that technique is the right technique. It's just that I might have gotten the numbers wrong. And again, if you put it in a Desmos, they should all look like the same graph. So that's squared minus 19x plus 79 with a remainder of minus 233. And it's a square there. So that's one way of expressing it. And as I've said before, this is another way of expressing it. Put the bracket out here, and you put the whole thing under a quotient like that. And essentially all it's saying is that once I factor this out, this was the quotient, and this is what I couldn't divide x plus 3 into. And when I put it outside the brackets, I'm essentially just multiplying this by that and creating that to get out. Hope that's clear, that they're the same result. Okay, looking at the next ones. This one will be shorter because it's being divided by a big polynomial. What about being a small polynomial being divided by a bigger one? It can't be factored. You'd have to find a way to factor the bigger one. Okay, x3 goes into the x over 4. How many times? Go x times. Now, do I have each term? Yep, I do. So x times here, and I get x to the 4 minus 7x cubed, minus x cubed plus 2x squared plus x. And there's no 0 here, so you're going to add, there's no numbers here, so you're going to add a plus 0 here. When I subtract it, I get 0. I get minus 6x cubed. 0 there, plus 0x. When I have plus 8x, and then I bring down the 0. And if I put this in, I get a minus 6. I get minus 6x cubed plus 6x squared, and that's the important part, is that this was a 0x squared, minus 12x minus 6, also important. These cancel. I'm left with minus 6x squared, which is 0 minus 6x squared. This is minus that, which becomes plus 20x. And this becomes plus 6. And I can't factor it anymore, so this is the remainder. So I would write this, and it's almost useless to writing it this way, that these are the factors. X minus 6. And the remainder is minus 6x squared. Well, it'd also be the first term written into it. So the power of 3 minus x squared plus 2x plus 1 times the minus x squared. And then outside of this is minus 6x squared plus 20x plus 6, if I got the numbers right. And just remember that there is a cube here, a square here, and a square there. And you might say, well, what's the point in that? And you'd be right. It's just so that you can understand what the remainders would be. And as I've said before, this last one, it's fine if you take it out of the bracket, but you can also put it in the bracket. If you put it in the bracket, it now becomes a quotient, which is the same as you just take the whole thing, you put it up here, you put it in brackets, and you put just a plus sign right here. That way you don't have to factor out this negative to figure it all out, but keep in mind that it would be all over this. That's if you kept it in the bracket. Both look pretty damn messy. And they just want you to get used to dividing really complicated things. And here's a good example. We have a small thing being divided by a big thing. It cannot come out. So since there is no divisor, it would be rewritten as this. It's just that divided by that. There's no possible result. There's no possible quotient. Now you might be able to factor this somehow and create something here that can be divided by this and treat that as its own bracket, and that way you'd have something here. But that's a hell of a lot of work. And then they go on to table 4. They want you to complete the table. So they're saying, what happens when I take this and I divide it by that? I'm going to get this quotient, and they want to know the remainder. Now, let you in on a little trick. I can guess right now 3 times 4 might have something to, and 41 minus the 12, the remainder might be something like 29. And let's see if that's true. So you can speed this up by just taking your divisor. And here they just want to make sure that you know the terms and where to place it. According to them, this is going to be the quotient. And they want to know what the remainder is. Well, 2x squared times this does indeed produce 2x cubed. And you get plus 6x squared. When I subtract this, I get minus 11x squared. And I bring down the 8x. And indeed, it becomes minus 11x times that. Times this becomes minus 11x squared. Minus 33x. And when I subtract it, these go away. And I get plus 41x. And then when I bring down the 41 as the last number, I know that it's plus 41. I get 41x. Oh, and I was way off on my remainder. And 3 times 41, oh, that's what I had to multiply. 3 times the 40, this instead of what I did. And 3 times the 41 is 123. And when I subtract them, I get negative 82. And that should be the remainder right up there. Now this one, they're really testing you. And again, it's important to put the things in the right box. They're not telling you what's divided by. They're telling you that this divided into something produce this with this remainder. Well, that's quite easy to do because as we've seen, that's going to result in this. Since we know when we took this mysterious thing and divided by this and got that with this remainder, this is a way of expressing it. And we also have learned that this is always going to be the original formula. So essentially this times that plus the remainder will give you the dividend. So let's expand that. This would be great if I'd done the answers here because it would be very satisfying. So how do you do it? Well, you expand it. And let me use my successful box method for this. You're going to take this as one part of the box. You take this as another part, and this is another part. I'm going to spread them out a bit. Give yourself some room. You're going to create a box that has as many boxes like that, and has as many divisions on this side as there are factors. There's 2, and many divisions up here as there are terms, rather, which is 3. And then you're just going to multiply. What's 3x squared times 2x? 6x cubed. What's 3x squared times 4? 12x squared. And you're going to probably add these boxes together. What's minus 5x times 2x? Minus 10x squared. What's minus 5x times 4? Minus 20x. So notice my writing is so bad here that it's important to put it in something readable. Minus 10x squared. What's this one going to be? Minus 20x. It's probably going to be added to this box, which is plus 16x. Helps if you put the symbols in too, just to remind yourself. And this last one, plus 32. Now don't forget at the end of it, we're going to subtract 3 from that 32. So we're going to get, the beginning of this is just going to be this first term, 6x cubed. And what's 12x squared? Right here, what happens when I add these? I'm left with 2x squared. These terms right. These terms right here, I can add. I get plus 2x squared. That's how the box system works. You just add like terms. And then when I add these terms here, I get minus 4x. So you're just adding like terms. And I'm left with plus 32, and then don't forget to subtract 3 after that. And the reason I'm subtracting 3 is because this remainder right there. So I'm ultimately left with 6x cubed plus 2x squared minus 4x plus 29. That should be the answer in the book. That's what we would put right here as the divisor. Or sorry, as the dividend. We're doing this one here. And that should work. Notice this box system will allow you to multiply polynomials much more quickly than other systems. I highly recommend you get comfortable with it. Speeds it up on a test. Now, this next one, they're saying what happens when I take this and divide it by who knows what, and I get a quotient with this remainder. You might say, how am I going to figure that out? Okay, well, we know we're taking this number, and we're going to be dividing it by a mystery. We're going to be dividing by a mystery. And we're going to get a resulting quotient of this up here, and this as a remainder. Well, don't you remember that I said, well, this times this plus the remainder will equal that. So let's write it out like that. Mystery factor, call it mystery factor A, times our 2x cubed, 2x cubed plus x minus 4. And when I subtract 5 will equal my quotient. Make it a little less confusing. Will equal my quotient. Well, like any mathematical process, if you're figuring out mystery box A over here, and it's multiplying this and then subtracting 5, to get this all alone, you reverse bedmass this whole mess. So I'm going to add 5 to both sides to get rid of the 5. Because it's this times that minus 5, and I'm trying to get that all alone. Okay, if I subtract 5 on both sides, this, or add 5 to both sides, this minus 9 becomes a minus 4. And that 5 on the left side disappears. Great. What's next? Well, it's clear that I would want to get A all alone. Since A is multiplying this big box, I would divide both sides by that big box. To get rid of it. On the left side, they cancel out. And on the right side, to figure out big box mystery A, I'm now just going to take this as my quotient, as my dividend, and divide it by this as a divisor. Now notice we have a small problem. It's 2x cubed plus x. We're missing an x squared. But if I do it all, it will give me the divisor that I'm looking for. So all I would do is make a little bit of room here and add the missing x squared, which is plus 0x squared. And now all I have to do is do long division. Now, once you learn synthetic division, you'll never go back to long division, because you can see how long and painful it is. So how does 2x cubed become 6x to the 4? It's multiplied by 3. X squared. No, it's just 3x. And this is interesting. Will this work? Well, we'll just see. So 3x times that becomes 6x to the 4. 3x times that becomes 0. 3x times becomes 3x squared. I think it will work. And then I get a minus 12x here. When I subtract it, these nullify. I get 2x cubed. This becomes 0. And I get, when I add 12x and 11x, I get minus minus. I get plus x. And then I bring down the minus 4. And then I say, well, how do I get 2x cubed from 2x cubed? I just multiply it by 1. 1 gets me 2x cubed plus 0 plus 0 plus x, minus 4, minus 4. When I subtract it, cancel, 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 cancel. So 3x plus 1 goes right here, was the thing. 3x plus 1 was the thing that I divided into this to get that with that remainder. But you can see the math formula, as long as you understand what happens between all these terms, you can put it in a mathematical formula and solve it. Notice that this all canceled each other out because it ended up being the exact term, which means plus 1. And of course, in math questions, they're not going to make it impossible. So the next one simply says, if I take this, and actually I can't quite see it, so I should copy this again. I'm only concerned with the last box. And by the way, I could have made some arithmetic errors, but I'm pretty sure that last one I didn't because it came out perfectly. And I will have to stop at this one. And this one's very simple. It simply says, when I take this and divide it by this, what quotient am I going to get? And they even tell you the remainder is 8, but you don't need that. You can just do long division and say, okay, all my terms are there, all my terms are there, so I'm going to start with 3x squared, and I get 3x cubed plus 6x squared. When I subtract this from that, I get minus 5x squared, and then I bring down my minus 6x. By the way, I should end up with a remainder of 8 if I did it right. My next term is minus 5x, and I get minus 5x squared minus 10x, and when I subtract it, I get plus 4x, then I bring down my plus 16, and I can see this is going to be plus 4, and when I multiply it out, I get plus 4x plus 8, plus 8, I'm not getting a remainder of 8, so I did something wrong. So if I did something wrong, go back. And try again. So the first one's definitely 3x squared. And I'm going to get 3x cubed plus 6x squared. When I subtract that 6x squared, I'm going to get minus 5x squared, and I'm going to bring down the 6x. That means I'm going to multiply this by minus 5x. By the way, this is a squared, and that's an x. And this is a squared, and that's a cubed here. And when I multiply by minus 5x, I get minus 5x squared again, minus 10x. And I'm left with 4x. Then I bring down the 16. Maybe that was what I did wrong. Yeah, I didn't bring down the 16. Brought down the wrong thing. And then when I multiply that, I'm obviously going to multiply by plus 4. And I'm left with, yeah, there. I did do just a simple transfer wrong. Shows what happens when you're tired. And then when I subtract those, I'm left with a remainder of plus 8. And sure enough, that's what I get, which means the quotient that I would put right there is this. So that means when I took this and divided by that, I got this as a quotient up here with a remainder of 8. I'm going to stop for now. That's part 1. It's not bad. You can see it's quite long and tedious.